Have discussed about expectation variance. Okay, now the new term called covariance we are going to discuss. Covariance using expectations. So I said you that expectation of x is denoted, variable is denoted with e of x, variance is denoted with v of x. Okay, so e of x, what is the formula you'll write? If it is a discrete one, we'll write xp of x. If it is a discrete continuous one, you'll write x f of x d of x. For variance of x, you can write in terms of, all these are discussed topics. I think this is the main formula, and after simplifying this, we got this formula. Right? This is the formula for variance. How many variables are there in these two? We have only one variable called x or y, any one variable only. Whenever I think not only univariate distributions, we have already discussed the bivariate distributions. Bivariate distributions are the distributions where there are two variables under study. So whenever we have two variables, okay, if we have only one variable means we call that as variance of x or variance of y. When we talk jointly about the differences between these two, we use the term called covariance. Okay, covariance. When we use the word called cooperative, okay, co-education. Okay, whenever we use the word like co, it means that there is a minimum of two or more than two. So under variance, we will have only one variable. When we come to the term called covariance, means we are going to talk about the variance between two or more variables. Covariance. So even though it looks like a new term, it's not a new term. Variance is related to only one variable. Whenever we have a bivariate distribution or trivariate distribution, to study the changes jointly between them, we use the term called covariance. So let us confine our study to only two variables. Covariance may be between two or more than two variables also. Covariance between two variables is denoted with COV of x comma v, which indicates covariance. Its formula is nothing but, in terms of expectation, variance means you are writing with e of x minus e of x whole square. Here you will write x minus e of x into y minus e of y. Okay, this is the formula for covariance of xy in terms of x comma y. So as we have x, you will write x minus x e of x. With respect to y, we will write y minus e of y. Okay, for variance means you will have only covariance. If I write covariance of x comma, if the two variables are the same, you will get x minus e of x into x minus e of x, which is nothing but expectation of x minus e of x whole square. Okay, so covariance of xy is nothing but one difference with respect to x, one difference with respect to y. So this is nothing but the formula for variance of x, where you will get square. Now let us simplify this. Let us simplify the formula for covariance of xy. So we know that covariance of xy, just now we wrote e of x minus e of x into y minus e of y. So I think you can multiply x into y. First term into first, first into second, second into first, second into second. Means on the whole, binomial into binomial, you are going to get four terms. xy minus x into e of y minus y into e of x, minus into minus plus e of x into e of y. So we can take this expectation to each and every term, then you will get e of xy minus e of x into, I said you that e of x is same as e, you won't get e square. So e of x into e of y minus e of y into e of x plus again e of e is nothing but again e of x into e of y. I think one term cancels. You will get e of xy minus e of x into e of y. This is the main formula for covariance, where covariance of xy is equal to e of x minus e of x into y minus e of y. On simplification, the same covariance can also be written as e of xy minus e of x into e of y. Now, likewise, the results on variance and expectation. We are going to discuss some results on covariance. So, what are the results we have discussed on expectation? What is expectation of a constant? I am just recalling those. Expectation of a constant is constant. What is expectation of Cx? C into expectation of x. What is variance of a constant? 0. What is variance of Cx? Whenever a constant is taken out of the variance, it will be squared. What is variance of Ax plus b? A square variance of x. I think these are the results we have discussed in the previous class. Expectation of a constant is constant. Expectation of Cx is C into E of x. Variance of a constant is 0. Variance of Cx is C square variance of x. Whenever a constant is taken out of the variance, it will be squared. V of Ax plus b will be a square into variance of x. These are the discussed results. Now, using these results, we are going to frame some results on covariance. The first one is nothing but show that covariance of Ax comma By is AB covariance of x comma y. So, covariance of Ax comma By you need to calculate, means in place of x you have Ax, in place of y we have By. So, what is the formula for covariance of x comma y? Covariance of x comma y is expectation of x minus expectation of x into y minus expectation of y. So, in place of x you have Ax. So, expectation of, in place of x you have Ax, y, By. Ax minus expectation of Ax into By minus expectation of By, where A and B are constants. We know that expectation of Cx is C into expectation of x. Ax minus A into expectation of x, using the above result. Similarly, By minus B into expectation of y. So here A can be taken out from both the terms, x minus expectation of x. From these two we can take out b common, y minus expectation of y. So a into b is nothing but ab. So whenever a constant is taken out of the expectation, it comes as it is. So as a and b are constants, you will get ab into expectation of x minus expectation of x into y minus expectation of y. So this is nothing but AB into covariance of x comma y. I think this is what we need to prove. This is the first result in covariance of x comma y. So the second result is covariance of x plus a comma y plus b is equal to covariance of x comma y. You need to prove this. Again, what is the formula for covariance of x comma y? E of x minus e of x into y minus e of y. So now we need to consider the LHS, which is nothing but x plus a comma y plus b. In place of x we have x plus a, in place of y we have y plus b. So put here x plus a minus expectation of x plus a into y, in place of y we have y plus b. Expectation of x plus a minus expectation of x is x plus into minus minus expectation of a. What is expectation of a constant is again constant. So expectation of a you will get as a again, y plus b minus expectation of y, expectation of b is b, b cancels a. So you will get expectation of x minus expectation of x into y minus expectation of y, which is nothing but covariance of x comma y, which is nothing but the RHS. Okay, we have two more results. Let us discuss in the next class. Thank you.